Good morning, children. In this module, we are going to learn about the static electricity. When we rub a silk cloth on a glass rod, the transfer of electron takes place from the silk rod to the glass rod. So when you are rubbing the glass rod with the silk cloth, the electrons are stripped away from the atoms in the glass rod and transferred to the silk cloth. So leaving the glass rod positive and the silk cloth as negative. So this leaves the glass rod with more positive than the negative charge. So it gets a net positive charge. Similarly, when you're rubbing comb on your hair or when you're combing the hair, the comb becomes a charged particle, and when you're keeping it near the running water, the course of the water changes. So due to this friction only, due to the static charge, you can see the socks is clinging to the sweater. You can see the balloons are sticking to the monitor because of the static electricity. In this, you can see the Van de Graaff generator. So this generates static charges. If you happen to touch the Van de Graaff generator, this generates charges and it passes through you, and you can see the hair strands are moving apart because they are charged. So what is charging? Charging is a process of transfer of electrons between the two objects that are rubbed together. So when you are rubbing a balloon on the hair, the balloon becomes negatively charged particle and it attracts the positively charged hair. So charged particles indeed attract the uncharged ones. Here you could see the balloon is attracting the bits of paper. Similarly, the charged comb is attracting the bits of paper. So there are two types of charges, the positive charge and negative charge. So like charges repel, like when positive and positive charges are kept together, they repel the same way the negative and the negative charges repel, and unlike charges like positive and negative, they attract. So rubbing a balloon with a piece of a fabric gives a negative charge. The two balloons will stick together if they have opposite charges. The two negatively charged balloons will repel each other. You can see this in this picture. Two negatively charged balloons are repelling, and the charged balloon is sticking to the wall. So the like charges repel and unlike charges attract. Here you can see the charged balloon is repelling the can. It means that both are same charges. But here the charged balloon is attracting the hair strands. It means they are oppositely charged particles. So what are conductors? So conductors are materials through which the charges can flow easily. The metals are good examples for conductors. So here are a few examples for conductors like silver, gold, copper, steel, even water. The sea water, which has minerals, are good conductors of electricity. Insulators are materials through which the charges cannot travel. So non-metals are the best examples for insulators. Other than that, we have plastics, rubber, um, and oil. Okay, here you could see the rubber, glass, oil, diamond, dry wood are all examples for insulators. Now we'll see what is static electricity. A stationary electric charge typically produced by friction, which causes spark or crackling sound or the attraction of dust or hair. Here when you're rubbing in the blanket, you could see the sparks of light coming out. That is because of static electricity. So static electricity is produced due to the existence of electric charges that are accumulated at a region. So such accumulation of the charges is very well observed in the case of insulator. So this is because of these materials do not allow the electric charges to flow through them. So conductors allow the flow of charges, so the charges are equally distributed. So accumulation of the charges does not happen in conductor. That's why static electricity is not observed in conductors. So here the balloon is an insulator, in that the accumulation of the charges you could see, but in the metal, since they are conductors, the distribution of electricity is happening. So you can see only the dynamic electricity in the case of metals or conductors. Okay, so this is an electroscope. It is used to test whether an object is charged or not. So it has a brass disc on the top, and it has a brass rod, and you have a metal foil inside this. Okay, now what we do is, initially a charged object is being kept touching the electroscope, so that this is charged. When it is charged, the metal strips will move apart. When it is uncharged, in case you are touching any object and that is an uncharged object, then the metal strips will be staying together. Now initially the electroscope is charged with a charged object. Now if you want to test an object if it is charged or not, you are just placing it near the electroscope. If it is having the same charge as before, then the metal strips will move apart. But in case it is of opposite charge, what happens is the metal strips will come closer to each other. So this shows that the charged object is of opposite charge. So this is how we test whether the object is charged or it is belonging to the same charge or opposite charge. So if in case if you are touching the charged object, it loses the charge. The charged body loses its charge if we touch it with our hand. This process we call it as discharging. When the accumulated charges are released, we call it as discharge. Now, earthing. Earthing is a process of transferring the charges from the charged object to the earth. Now here you could see this is the charged object, and the person is touching it, and through him the charges moves to the earth. So this process of transfer of charges to the earth, we call it as earthing. So when you are walking on the carpet, you would accumulate charges in your body due to friction. Okay, at that time when your body is charged, when you're walking on the carpet, your body is fully charged. When you touch a metal object, you could feel a spark. Here you could see when you touch any metal knob, the spark. So this is because of the discharge, so discharge of the charges. When the negative and the positive charges meet, they produce tiny streaks of bright light and sound. This process is called as electric discharge. Okay, now this one, when electric discharge happens, you could see a spark there. To see the spark, the accumulation of the charges should be much high. For the electrostatic discharge to produce a spark, there need to be a certain amount of voltage difference between the two charges. Spark. An electric spark is an electric discharge that occurs through a medium, often air or other gases. Now the same concept is when the discharge of the charges occur in sky, we call it as lightning. So what is lightning? So lightning is a giant spark of electricity in the atmosphere between the clouds, the air and the ground. So with this we come to an end of this episode, children. I hope you understood. Please answer the questions, okay? So I have given you define the following questions. So define the following questions, children. So give reason. The tiny streaks of light is produced when positive and the negative terminals meet. When balloon is rubbed on hair, it attracts bits of paper. Sometimes crackling sound is heard while taking off a sweater during winters. You have to identify the conductors and insulators in this picture. Draw a neat label diagram of electroscope. So write everything in your notebook, children. Thank you. Take care.